Hi everyone, it is Miss Sunberg. We are looking at today page 10, and today we're going to explore this graph here that's called the phase change diagram. And what this is, it's a graph that's showing you how the temperature, and the temperature is, on the y-axis versus the time, okay? Because things don't just go instantaneously from a solid to a liquid or a gas. It takes some time to do that. So if you could find this page, I think it's page 10 in your packet, we're going to get started. So here we go. When you have a substance, and it starts down here, and the temperature is a lower temperature, we call that substance a solid. So you're going to want to write a solid right here on this line. Okay? So it is a solid from this point to this point. And right at point B, right here, we call that the melting point. Okay, so right at that point is where it starts to melt. Now it continues to melt through this time. It doesn't just melt instantly. It kind of builds in temperature, or it stays at the same temperature, but it stays at that temperature for a given amount of time. So it's just kind of gaining kind of energy, making sure all the molecules are there, and it's going through melting at this rate. Okay? Then, once it's done with melting and all of the molecules have melted and it's hit that certain point, it then turns into what's called a liquid. Okay, so it remains a liquid all through here as it gains temperature. The molecules start moving and increasing more and building more speed and moving more around. And then at this point right here at point D, we call that the evaporation point, or the point where it becomes a gas, and now it continues to evaporate, where it's moving from a liquid into a gas. Evapor, P-O-R. Evaporation. Okay? And then as it evaporates, and then eventually all the molecules will turn into a gas. So this is kind of the pathway that we have as we go up our phase change diagram. Now, the interesting thing is we can also go down our phase change diagram, and we know that we can turn gases into liquids. Okay, so if we're going down this way, we can go gases into liquids. So we can go this way, moving this way would be condensation. And then it's a liquid for a while, and now if we're moving a liquid into a solid, we can call that freezing. Oops. So these are some points here that you guys need to be aware of as you're moving through this. If I'm using the blue pen, I'm going down the graph, but if I'm using my red pen, I'm moving up the graph, okay? So hopefully, as you read through this phase change diagram, you'll understand that the substances don't just instantaneously go from one to the other. It kind of happens over a time period. So as you move through here, knowing those kind of points, you should be able to now go through and answer some of these questions that are in here. And just so you know, a solid, let's zoom in here, a solid, so right here during this phase, a solid has a defined volume and a defined shape and a defined volume. I guess that's the best way to describe it. I can move these. I'll just erase these here. A liquid here has, when we look at a liquid, so you know one of the test questions, or the questions on this sheet, asks about liquid having a defined volume. So you can pour whatever amount of liquid you want. You can pour 10 milliliters, you can pour 500 milliliters. You can pour 700 liters. I don't care how much you pour, you're going to have a defined volume. But when you pour that volume into anything, whether it be the top of a table, a pool, or a cup, it takes the shape of the container. So it has a defined volume, but no defined volume. And then up here, gas, when we look at a gas, it doesn't have a defined volume and it doesn't have a defined shape. It takes the shape of kind of whatever container it's in, but it will also fluidly flow from one shape to the next. So if you take a look at all the gas in your house, if you open the doors, there's going to be some gas molecules that flow in and out. So it just kind of fluidly moves. So there's no defined shape or defined volume. So hopefully that helps. You complete the rest of this page now that you know where gases are, where liquids are, and where solids are on this graph. Bye, guys.